Hello, 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 beautiful bunnies that listen. All right, so we are coming in here and we are going to be working on day 4. I'm going to do all 5 questions with you. All right, so for the first one, we have here, we're going to create 2 numerical patterns. We're going to have pattern 1 and pattern 2. And then you have to find which pattern matches up with it. And since these are horizontal, I want you to go ahead and make your T-chart horizontal too. It'll make it easier for you, okay? So this is, I'm going to call this P1 and P2, pattern 1 and pattern 2. All right, pattern 1 starts with 2. Okay, perfect. And then you add 4 every time. So what I like to do is I like to make little hash marks like this so that I can keep my patterns matching up, my top term and my bottom term. Okay, so pattern 1, I'm going to start at 2 and add 4 every time. So 2 add 4 is 6, 6 add 4 is 10, add 4 is 14, add 4 is 18, add 4 is 22. All right, then on the bottom, it says start with the number 5. There is 5, and it says each time the rule is going to be to multiply it by 3. So 5 times 3 is 15. 15 times 3 is 45. 45 times 3 is going to be 100. No, yeah, 45 times 3. I'm going to come down here and do it right here. Is 135. I'm going to put that right here. And that might be far enough. Let me see if there's anything up here that matches. Okay, so the first terms, remember that it says pattern 1 and pattern 2. So these are all labeled pattern 1 and pattern 2, pattern 1, pattern 2. And the first term is going to be 2 in the pattern 1 and 5 in the pattern 2. So you can cross off any that don't match with that, okay? So we've got 2 and 5, that works. 2 and 5, that works. 4 and 3, ooh, you can mark that one out. And 4 and 3, you can mark that out, okay? So this has got 2 and 5 for the first term. Now let's look for the next one. 6 and 15, 10 and 45, 14 and 135. This works and it matches up with the one we created. This other one is 2, 5, 8, 8. This is not it. Okay, we can go ahead and mark that out. All right. Over here, we are going to do another pattern one. It says consider the rule for pattern P and Q. So when we hear patterns, we know we're making a T-chart. All right. So we've got pattern P is on this side, pattern Q is on this side. Pattern P started with 6 and add 5 every time. So put 6 here, and like I said, I like to make the little lines like this so I can keep them all matched up. 6, add 5 every time. So that's 11. 11 add 5 is 16. Add 5 is 21. Add 5 is 26. Add 5 is 31. And maybe stop there. Now let's see what happens next. So Q, it says start with 4. That's the first one. And then multiply by 2. This is 8, because 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. All right, so now what we're going to do is we're going to see if we can determine the relationship, okay, between this term and this term. Remember when we talk about relationships, we talk about they're like holding hands, okay? So from the left to the right, what is the relationship between the two numbers? Okay, so this one is going from 6 to 4 is minus 2. 11 to 8 is minus 3. 16 to 16 is minus nothing. All right, so far I don't really see any kind of relationship pattern. Why don't we just read their ideas and see if we can eliminate any, okay? Because we know our pattern is correct, okay? So it says the second term of pattern Q, that's here, that's 11 and 18 because this is the first term, this is the second term, the third, the fourth, the fifth term, okay? So let's see. The second term of pattern Q is greater than the second term of pattern P. So let's see. Pattern Q, the second term is 8, and pattern P, the second term is 18. So is pattern Q greater than pattern P? No, it is not. We can mark that one out. All right, now this one wants us to look at the third term. So here's the third term right here. It says the third term of pattern P is equal to the third term of pattern Q. That is correct. They are equal. And let's just look at the other ones to make sure we're, not off base. Oh, wait a minute, look here. It says which two statements are true. So we've got to find two. We found the first one. All right, let's look at the next one. The fourth term of pattern Q is twice the fourth term of pattern P. So we're going to come down here and we're going to go to the fourth term. That's 21 and 32. And it wants to know, is Q twice of P? Well, 32 is bigger than 21, but it's not twice. So we can mark that one out. All right, so let's look at D. This is D says, look at the fifth term. Fifth term is 26 and 64. And it says, is pattern P half of this? Well, half of 64 is 32. So that's not half. So we can mark that one out. Okay, and then this one wants to know about the sixth term. So we've got the sixth term for P. Now we need to figure out the sixth term of Q. Remember, this went 4, 8, 16, 32, 64. So every time it's multiplying by 2. So to find this one, you have to take 64 and multiply by 2. So let's see. 4 times 2 is 8. 2 times 6 is 128. So this is 128. Let's see if E is right. It says the sixth term is pattern Q is 97 more than pattern P. Well, let's see. If we take 128 and we subtract 31, let's see if it's really 97 more. 8 minus 1 is 7. And then I can't take 3 away from 2, so I have to borrow. This turns into 12. 12 minus 3 is 9. Oh my gosh, Ms. Ross, it's 97 more. That is correct. Those are the two that are correct. Okay? All right. For number 3, this one was actually so weird and confusing to me that I had to go to Mrs. Letchworth and get her to help me figure it out. Okay, so this says here that the points on the coordinate plane show two different patterns. The first pattern gives the x coordinates of the points, and the second pattern gives the y coordinates of the points. Okay, so I'm going to draw a little T-chart here, and I'm going to write x and y. And what I want you to understand is that this first point is run 1, jump 2. So this is 1, 2. This second point is run 3, jump 6. So it's 3, 6 for the coordinates. This is run 5, jump 10. And this is run 7, jump 14. And this is run 9 and jump 18. Okay? So those are the coordinates for them. So if I literally had to write this down, this point right here would be 1, 2, right? All right, so what it's asking is it says, how would the locations of the points on the coordinate change if the patterns for both coordinates began at 0? So what if our first point was right here? What if our first point was 0, 0? So instead of our first point being at 1, 2, what if it was at 0, 0? How would they move? So would they shift 1 unit to the left and 2 units down? So let's see, would that work? If we moved over 2 units to the left and 1 unit down, would that end us up at 0? No, that would not work. If we shifted over 1 unit to the left and 2 units down, that would work. But not 1 left and 2 down. So this is not it. Okay. Wait, actually, that's correct. No, sorry, guys. I apologize. That is correct. So if it moved over 1 unit, which would put us at the y-axis, and moved down 2, so if it moved over this way 2 and 1 unit down, we would end up at 0. So all the points would have to shift over just like that. So this actually is correct. All of the points would shift 1 unit to the left and 2 units down. The other ones do not work. If it shifted 2 units to the left, 1, 2, you'd end up off the page. So that's not going to work. If it shifted 5 units to the left, you would be way over here. So that doesn't work. And they're definitely not going to remain the same. If you have your first point at 0, 0, the points are going to have to move over. Okay, here we go. Next one. A rectangular tank has dimensions 42 inches, 20 inches, and 18 inches. Water fills the tank to a height of 8 inches as is shown, okay? How much more water is taken to fill the tank completely? Okay, so you've got length times width times height equals the volume, correct? Okay, so let's figure out the volume of the whole box first, okay? Let's just do the whole box. I'm going to label the length, the width, the height of the entire box. So the length is 18 inches. Write that. Is 18 times the width is, I'm gonna label this in pink. The width is 42, so you can write that here, times 42, times the height, I'm gonna label that in blue. The height is 20 inches, okay? So I'm gonna write that right down here. So if I want to find the volume of the entire box, I'm going to take out my handy dandy calculator. Let me go grab one. Hang on. Where's the calculator? Let me see if I can grab my phone. My phone has a calculator on it. Where is my phone? See if I can find my phone. I apologize. Oh, I located it. Here we go. So I'm going to open up my phone and I'm going to open up my calculator app. So I'm going to, since these are huge numbers, I'm going to use my calculator. So if I've got 18 times 42 times 20, the volume of, whoa, let's try it again. 18 times 42 times 20. Well, we were right. Okay, so the volume is 15,120. We're going to write this down. So volume of the whole box is 15,120. Okay, so that's if you want to fill up the whole box, but there's already some water in there, right? So let's figure out the water that's in there. Okay, so write that here. Water that is in there. Water in, how about already? We'll write water in already. Okay, so the water that is in there already is 18 long, 42 wide, and only 8 inches tall. Does that make sense? Okay, so let's figure out that already. So we've got 18 inches wide, long times 42 inches wide times just 8 inches tall. So here we go. So let's go here. We can also do 18 times 42 times 8. So what's in there already, the volume of what's already in there is 6,048. Okay, so, but we only want to know, it says here, we want to know how much more water is needed to fill the tank completely. So we need to know this empty space here, okay? And there's 2 ways you can do it. You can either, what you can do is you can solve for the whole box and subtract out the volume that's already in there. That's the route I'm taking, okay? So what I'm going to do is I'm going to take 15,120 for the entire box. I'm going to subtract out 6,048 for the water that's already in there, and that will tell me what's left in this open space. Okay, so since I already have my calculator, I'm going to type it in. So I've got 15,120 minus 6,048, and that's going to give me 9,072. I'm going to write that right here. So the volume of this section that is missing is 9,072. Another way that you could solve it is you could come over here on this side and you could realize that the entire height is 20, and that if you subtract out this 8, then just this part, okay, right there, is 20 minus 8 is 12. So what you could do is you could do 18 for the length times 42 for the width times 12 for the height, and then you wouldn't have to subtract. So let's see if that works. 18 times 42 times 12 gives us, there it is, 9,072. So the missing part is 9,072. That is a lot of math. That is a very hard math problem. All right, here we go. A teacher asked Holden and Cecilia to find the volume of a rectangular prism. They count 12 cubes on the bottom layer. Do y'all call the bottom layer the base as well? I know we do. So the base is the bottom. The base is 12. And I have taught my children that volume equals length times width times height, or volume can equal the base times the height. Also known as one layer, just one layer. How much is one layer worth? Okay, so which process could Holden and Cecilia use to determine the total volume of the rectangular prism? So if the base is 12, if just one layer is 12, because if the base is 12, then this layer is 12, and this layer is 12, and this layer is 12, and this layer is 12, right? So if just one layer is 12, then you can just multiply by how tall it is. And this thing is 5. It has 5 for the height. It's 5 blocks high. So you can do 12 times 5 to figure out how many blocks are in the whole thing, and that would give you 60 cubes in the whole thing. So Holden and Cecilia could add 12 to 4 to find the volume of 16. No, the volume is not 16. The volume is 12 plus 12 plus 12 plus 12 plus 12. All right, let's see. Holden and Cecilia could add 12 to find a volume of 17. No, the volume is not 17. The volume is way bigger than that. Holden and Cecilia could multiply 12 by 4, but that doesn't tell me the entire thing because it's five layers high. Okay, so that won't work. Holden and Cecilia could multiply 12 by 5 to find a total volume of 60. Ding, 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 ding. That is correct. All righty. Love you guys. We'll talk to you soon. Bye.